Okay, now that we have our truth table facts for the first three of our connectives, the negation, the conjunction, and the disjunction, we're going to do the same thing with the conditional and the biconditional. Okay, so we're gonna do these separately. So remember, the conditional, the words that go with the conditional are what? How do you know you're dealing with a conditional statement? Perfect. It's if and then. When you see if then, you know you're dealing with a conditional statement. So here's something that's true for the conditional statement that's different than the other four connectives. The conditional statement is the only one for us that the order is going to matter. Okay, that's very important. When you're doing the conjunction, we're doing the disjunction, it doesn't matter if the true comes first or the false comes first. It doesn't affect the result. Okay, the order of the statements doesn't matter, but for the conditional it does. So I want to tread slowly here because this is the one probably, I don't think it's difficult, but this is the one that your brain's going to rebel against it first the most. So here's my statement we're going to deal with. Okay, so if you score above 90, then you get an A. And just to remind you, this is stuff we've talked about before. The part that comes after the if, that you score above 90, that's called the condition. That's kind of the test of the statement. That's the part that you have to satisfy. And then you get an A, that's the consequence. Okay, so here we go. I'm gonna just fill in my truth table in the normal way that we've learned to do from our other connectives. Now I want to go through and I want to determine the truth value of each of these things. So the first one, I've got the statement P is true and the statement Q is true. So what that means is if the statement P is true is, let's say I got a 95, that's a score above 90, that's true. And then I get, since Q is true, you got the A. So here's the thing. You scored a 95, you got an A. Did everything happen the way it was supposed to there? Yes. Okay. When you go into your grade book later and you see you got an A, that's exactly what you were expecting. And so that is true. So when you have if a true statement, then a true statement, that results in a true statement. Okay, fantastic. So now this one, the next one, P is true, so the condition is true, the consequence is false. So what that means is you got a 95, that's true, right? It's above 90. But then when you go into your report card, you got a B. Did the statement function the way it was supposed to? No, because you met the condition, you scored above 90, but the output was not what it was supposed to be. You were supposed to get an A, you got a B. So that one's false. Are we tracking along so far? Yeah, I think that normally for most students, my experience is those two make perfect sense. It's these last two that you're going to have to train yourself, probably. Okay, I'm just forewarning you because I want this to be as relaxing as possible. So statement P, if statement P is false, that means you didn't score above 90. You got a 79. Now here is the truth about this statement. When you don't meet the condition, this statement no longer has any relevance. And it doesn't matter what you got on your report card according to this statement. Okay, this statement only is applicable to one situation. What's the one situation this statement is applicable to? If you score above 90. So if you don't score above 90, this statement has no relevance. So if you score above 90 and you got an A, well, what that means is you didn't meet the condition. It doesn't matter what the consequence was. This is that's true, okay, logically. And again, I'm going to repeat this a couple times because I know your brain's contorting. I get it. Okay, the first time you ever see this. The reason that that is considered a logically true statement is because since you didn't meet the condition, this statement has no bearing on what the consequence is going to be. The consequence can literally be anything now because this statement is not dictating what happens. And so that applies to the last one. False. Okay, you got a 79. Again, since you got a 79, it doesn't matter what the consequence is according to this statement because you can get an A, you don't have to get an A. This statement doesn't deliver the result. So if you got a 79 and you got a C, that's fine. Okay, it doesn't matter again because you didn't meet the condition. So that's going to be a true statement as well. So looking at the pattern here, the only time your conditional statement is false is if you met the condition and you did not get the prescribed consequence. True, then false. So notice that means the order matters because if they go false, then true, that results in a true. That's why I say that this is the only statement where order matters. So you've got to be careful. Okay, so however you code this into your brain, you have to remember that if true, then false, you met the condition, you didn't get the consequence, that is the false one. All the others are true in the conditional statement. So here we go. I'm going to do the first example along with you, okay, because I know this is a new and goofy one. So example 1, we are going to construct the truth table for squiggly Q, then P. So firstly, I'm going to fill in the truth values in my normal way. So I've got true, then true, true, then false, false, then true, false, then false. Those are my 4 usual order of the rows. Okay, so I'm going to take your advice here. What should I do first to do squiggly Q, then P? Yeah, we need a squiggly Q column. Okay, so I'll do that. So squiggly Q. That's the negation. The negation is like a light switch. It just flips the truth values. So for Q, I'm just going to reverse the order of these values. So instead of true, false, squiggly Q is going to be false, true, false, true. I'm guessing that you don't have any problem with the negation. So now I'm going to do a squiggly Q, then P. This is my conditional statement. This is the statement that order matters. Okay. What I like to do, again, I am easily distracted. So what I like to do is I like to put an arrow above my columns to indicate the order the conditional statement is going in. So I'm going from squiggly Q, then P. So up here, I'm going to put an arrow going in that direction, just to remind me that I'm reading the columns backwards as I do this, okay? That's a tip for me. If that doesn't work for you, come up with your own little way to remember, okay? I know what works for me doesn't necessarily work for you. Everybody's brain is a little bit different. But here we go. Now we're going to do this. So the first one is if false, then true. Well, what's always the output if the condition is false? True. Yep. So that's going to be a true statement. The next one is if true, then true. What's the result? True. The next one is if false, then false. That is true. Now here's the last one. The last one is if true, the condition is true, the consequence is false. You got above a 90, you did not get the A, so the output there is false. Great. Excellent. I heard a lot of falses there, so that makes me happy. So I would like you, I'm going to give you a couple minutes. Same thing, exercise 1, just going through this and developing your memory. I'm going to get going. Compare your work with mine. If you deviate from me at all, that is a great opportunity to ask a question and get some clarity. Okay, so remember, I've said this a bunch of times. Questions are not interruptions or bothers. They mean you're learning, and I love it. So ask whatever you need to. So I'm just going to go through what I would normally do. I've got some squigglies here, so I'm going to do a column for squiggly P. If you did the column for squiggly Q first, that is perfectly legitimate. There's no better or worse order to do these two things in. So squiggly P is going to be false, false, true, true. Then I need a column for squiggly Q. So squiggly Q is going to be false, true, false, true. And now here's what we are practicing is the conditional. So I've got squiggly Q, that's the first one, then squiggly P. So again, just because I'm easily distracted, I'm going to draw an arrow above that. So we're going if squiggly Q, then squiggly P. So we're going in this order. Now, if you did your squiggly columns in the opposite order, then your arrow is going the other way. Okay, so just know that. But we will get the same thing because we're going in the same order. So I've got false, then false. That is true. I've got true, then false. Okay, this is I met the condition. I did not get the consequence. That is the false one of my conditional statements. False, then true is true, and then true, then true is true. And there we go. There is my truth table. We should all have the same TFTT. As long as you built your truth table like I did, which I'm hoping you did, because in my math lab, they assume that as well. So we should all have the last column of TFTT. All right, same thing, just this one, last one on the front page here, just has 3 statements, just because that's what we've done before. So go ahead and give that one a try. And I see a lot of you going to your notes. Let's do a little reminder here. Just in case, I'm guessing you're probably trying to remind yourself of the initial 3 columns. Am I right on that? Great. Then let's review that because we're going to do another one at the top of the next page and you'll get to apply this. So we want to make sure that we have 8 different rows here. And so the process I gave you to construct those 8 different rows is like this. The first column, let's do 4 trues and then 4 falses. So 4 and 4. Maybe that helps refresh your memory a little bit, maybe not, but if it does, the Q column, instead of 4 and 4, what did I say last time we should do in the next column? 2 and 2, alternate every 2 now. Okay, we did 4 and 4, we did 2 and 2, then the last column, I'm going to alternate every how many? Every other. Yeah, it's just going to go true, then false, then true, and then false. And you can see that creates 8 distinct combinations of trues and falses. There's no rows that repeat. And so just to give you a quick nudge before I let you finish this problem, where are you going to start making rows, or excuse me, making columns? Yeah, you're gonna first focus on the parentheses, and then yes, in the parentheses, in order to do that, I need the squiggly Q. So do a squiggly Q column, do a parentheses column, and then finish off with the conditional statement column. You need 3 columns to finish this one off. All right, so let's see how you did with your truth table facts. Again, give me any questions you have. So the first one's squiggly Q. So the Q column is two trues, two falses. So we're just going to reverse that to two falses and then two trues. And we're going to do that again, two falses and then two trues. And there we go. And now I'm going to finish the parentheses. I'm going to take that squiggly Q column. So I'm going to put a little dot over that. And I'm going to use the conjunction, the and statement with the R column. Okay, you told me a little while ago that the conjunction is true when both are true. So I'm just going to go down those two columns and we're going to see. So the first one's true and false. So that's going to be false. False and false is false. True and true is going to be true. False and true is false. True and false is false. False and false is false. True and true. And then finally, false and true. So remember, since we all started off with the same order of our columns, okay, we should have the exact same column right here. And now, finishing this off, I'm going to take statement P, I'm going to put a check mark, and I'm going, that's the if part, and then the then part is what we just did in parentheses. Again, my habit is I'm going to put an arrow there so that I don't get confused on my order, because the conditional statement is the one statement that order is important. And so here we go. So I've got true, then false, met the condition, did not get the consequence. So that's the false one. True, then false again. That's the false one. True, then true is true. True, then false. Again, that's the false one. False, then false. That's true. False, then false. That's true. False, then true, that's true. And finally, false, then false, that's true. That should be our last column. So far, so good? Just a couple more. I kind of reinforce the conditional a little more just because it is, I think, my opinion, the one that you takes, I think, the longest to learn. So we just got a couple other problems that we're going to do here. So exercise 2 up at the top. It's just another one of the same sort of things. This time it's a little bit simpler. You've just got a parentheses. I've put the parentheses as the condition this time, just so that you got to go through the process again. So give it a go, and we'll see how you do. Excuse me. Okay, this one just needs 2 columns to get to the finish line. We need a column for the statement in parentheses, which is an or statement. The disjunction is true when either one of the statements is true. So P or Q, I'm going to put a little dot over each of those so I don't lose my focus. So true or true, that's going to be true. True or true again. True or false. True or false. False or true. False or true. False or false, and false or false. So the first 6 ones in that column are true. The last 2 are false. And now in this one, what I did that was different than the previous one is the statement in parentheses is the condition. And so I've got that and then R, and I'm going in this direction right here. And so I've got my P or Q and then R. So there we go. That's what I've got. And now let's go ahead and fill this out. So true, then true. That is true. Remember, the only time the conditional statement is false is when it's true, then false. So the next one, true, then false. There we go. True, then true. True, then false. True, then true. True, then false. And then the last 2 are false. They begin with a false. So logically, they are true statements. So you should have a T and then an F, a T, then an F, a T, then an F, and then the last 2 are T's. All right, one more of these, and then we're just going to combine all the skills that we have from this unit so far in the last exercise on this front page. So here we go. Exercise 3, one more straight truth table. Again, you're going to need 3 columns. What I did on this one that's a little different than the others, and the reason it's here is this time the conditional statement is the one in parentheses, and then it's overall a conjunction because it's joined with an and. All right, let's see how you're doing on this one. So again, starting in those parentheses, I need a squiggly, so I need a squiggly P. So we'll start with that. So squiggly P. P is 4 trues, 4 falses. So we will reverse the order of those those 8 things. Sorry. And then this time the conditional statement's in parentheses. So I've got squiggly P, then Q. So here's squiggly P, here's Q. I'm going in this order right here. So false then true is true. False then true is true. False then false is true. False then false is true. True then true is true. True then true is true. And then the last ones are both true then false. So the last ones are both false. And then finally, we're going to take that statement from parentheses, the squiggly P, then Q, and we are going to use the conjunction, which is the and statement, with R. So we're going to take this one and then the R statement right there, and we are going to do the and statement. The and statement is true when both are true. So here we go. First one, true and true is true. Second one, false and true is false. True and true is true. False and true is false. True and true is true, and then false and true is false. And then true and false is false, and finally false and false is false. And that is the last column we should get. Am I going too fast? Is everybody keeping up okay? All right, so last thing, we've done this before. We did this the last section when we talked about the conjunction and disjunction. We're going to take this in 3 separate steps. That way I don't get ahead of you and you're getting all the information you need. What I would like you to do is read through the statement, and then I would like you to write down the 3 simple statements we are going to use for this problem. I'm going to give you about 30 or 40 seconds to do that. Okay, so our statement is, if you use top power, then you will not feel tired and you will get a solid workout. So the first thing we do in any situation like this is translate into simple statements. So reading through, just using them kind of in the order we see them. How about statement P? What do you want that to be? Okay, you use top power. Or if you abbreviated top power, I get it. We're saving a little time and ink. All right, how about statement Q? Okay, so I'm going to amend that just one little bit, and I'm really glad you said that. We always define our simple statements positively. Okay, so I'm not going to make Q, you will not feel tired. I'm going to make Q, you will feel tired. We always, when we define our simple statements, we always leave the negation out. We leave the nots out. We put the negation back in with a squiggly in our next step. Okay, so don't forget that. That is sometimes a common mistake, and I get it. I understand why you want to do that, and I understand in the first section when we were talking about the negation, our book used some examples that the simple statements had negations, but I mentioned at that time that is not the convention. That was just when we were talking about the negation. And then R is you will get a solid workout. Okay, once you've got that, step 2, I'm going to give you another 30 seconds. I would like you to write this in symbols. Okay, so here we go. The whole statement starts with the word if. So since it starts with the word if, that means it is a conditional statement. So I'm going to draw an arrow over here for my conditional statement. What comes right after the if? Okay, P. Now there is a comma. What does that comma tell me? I'm sorry? Where am I going to put do I need parentheses on the left? You're 100% right when you said that. We do need parentheses. Do I need parentheses on this side of the comma? No, because there's just one statement. So P is the only thing on this side of the comma. But then you're right. Commas communicate to us that there's going to be grouping. And so the stuff on the other side is going to be grouped. Then you will not feel tired. This is where we put the squiggly back into Q. So squiggly Q, you will not feel tired. And going to use the conjunction, the caret, and you will get a solid workout. That is R. So the three keys here is the word if tells me it's a conditional statement. The comma tells me all about the grouping. And then the and tells me what I need to do in the parentheses. If you have a question about that, fantastic. I can come to you. If not, get started with the truth table. Let's knock that out, and then we'll finish up this section with our talk of the biconditional, the last remaining connective. All right, I'm going to get started. If you're still working, keep working. Check your columns with my columns. Interact with me as you need to. So the first thing I need to do is these parentheses. So I need a squiggly Q first. And so when I go and do the squiggly Q, in fact, I'm just noticing, because I'm not super creative, this is the same truth table as example 1. I don't know if you noticed that, but that's the little secret. So I guess I accidentally repeated something, but I'm just going to run through it real quick just in case. So I'm going to negate the Q column. So that's false, false, true, true, false, false, true, true, just making all those opposites. I'm now going to use the conjunction in the parentheses, so squiggly Q and R. So I'm going to put a dot over those two columns, probably like I did last time I did this example on the other page. So the and statement, true and false, is false. False and false is false. True and true, that's the true one for the conjunction. False and true is false. True and false is false. And then we got false, and then we've got true, and then we've got false. And last but not least, I am now going to do the conditional part to this. And so that is going to be starting with P and going to the squiggly Q and R. And I'm going to go in this order right here. So true, then false is false. That's the false one. True, then false again is false. True, then true is true. True, then false is false. And then the last four all start with the false. And because the condition is false, that means logically my conditional statement is going to have a result of true. And there's my last column. We all good there? All right, so we did a whole bunch of examples on the conditional, probably overdid it a little bit, but better too much than too little. We have plenty of time. And so the other connective is the biconditional. And when I introduced this connective to you, I told you that the biconditional, since the arrow, the reason the arrow has two arrowheads on it is because the biconditional is a 2-for-1 statement. It's saying that this is a conditional statement in both directions. So what we've really got here is if we read this statement to the left, we've got if P, then Q, and then if we read the statement backwards, what we've got is if Q, then P. That's what a biconditional statement is. It's just a conditional statement in both directions. Okay. And so what I'm going to do is I'm just going to, since we've just practiced the conditional statement, I'm just going to evaluate the truth value in each direction, and then we'll use the conjunction to determine what the overall truth value of the statement is. So on the first one, when P is true and Q is true, when I go from left to right, I've got if true, then true. So that is a true statement. And then when I go from right to left, when I read it backwards, I've got if true, then true, that is true. And so it's true in both directions. So that means the biconditional is true statement. The second row, I've got P is true, Q is false. So let's do this left to right. If P, then Q. That is if true, then false. That is the false statement. And now go backwards. When I go backwards on this, I've got if false, then true. That is true. So I've got false one way and true the other way, since it's connected with an and, because it's both of these. The false and true is going to mean that this is false. Now with the row P is false and Q is true. So when I go left to right, I've got false, then true. Okay, that is true. When I go right to left, when I flip the order around, I've got true, then false. That is false. So again, one of those ends up being false. So when I combine them together, it's false. And then last but not least, when both P and Q are false, going left to right, false, then false, that is true. And then going right to left, flipping it backwards, false, then false is true. And since both are true, that is true. So again, now the biconditional, we return to where the statement, the order doesn't matter as you're considering your trues and falses. And how would you summarize that for me? When is the biconditional true? Boom! Yes, that is very well said. If both statements have the same truth value, the biconditional is true. Okay. When either one of them is false, the biconditional is going to be a false statement. So with that in mind, exercise 5 right below is just a very straightforward reinforcement of that summary we just did. So go ahead and do the truth table for exercise 5, please. Okay, so on this one, I've got Q if and only if squiggly P. So I need a squiggly P column, so I'll do that, squiggly P. So instead of true, true, false, false, I've got false, false, true, true. And now I'm going to now join Q and squiggly P together with the biconditional. So again, just to reinforce, the biconditional is true when the statements have the same value. So let's look. I've got Q and squiggly P. Just going to put a dot above both those columns. So I'm looking at the right ones. So I've got true if and only if false. Those values are different. I've got false if and only if false. Those values are the same. True if and only if true. Those values are the same. And then false if only if true. Those values are different. So that last one's false. All right, we're getting close to the finish line. I've got just one more biconditional example, and then there's just a couple details we've got to mop up on the top of the last page. So here's what I'd like you to do in exercise 6, please. Do the first 2 steps of this problem. Identify your 3 simple statements, and then write the statement in symbols. I'm going to give you about 90 seconds to do that, and then we'll finish up, and you can do the truth table on this. Okay, so the statement is if the dam holds, then we can go fishing. Notice the comma, if and only if the pole is not broken. Okay, so statement P, I'm going to say the dam holds. Then statement Q is we can go fishing. And then finally, statement R is the pole is broken. Good. So now let's write this in symbols. So it starts with the word if. If means I'm going to have a conditional statement here, so I'm going to put an arrow. So it says if the dam holds, then we can go fishing. And notice the comma. What that tells me is that if then statement is on the same side of the thing. So I need parentheses there. So if the dam holds, P, then we can go fishing, Q, and there's going to be parentheses around that because they're on the same side of the comma. If and only if, that is the biconditional statement. And then the pole is not broken, that's squiggly R. So if you have a question about that, let's interact on it. If not, move forward and go ahead and do the truth table for that statement. So we just need 3 columns for this. I'm going to do a column for the parentheses first, the if P then Q. This is the first thing we talked about today. This is a nice review problem. So the first thing we talked about today was the conditional statement. And the conditional statement is the only time the conditional statement is false is when you have the true then false. So we're going to use the P in the Q column. So true then true, that is true. True then true, that is true. True then false, that is false. True then false, that is false. False then true is true, false then true is true, and false then false. The last two are both true. So there's my first column, the conditional statement, pretty straightforward. Then I need a squiggly column for R. So R goes true, false, true, false, true, false. So it's just going to reverse to false, true, all the way down. And then last but not least, I'm going to take the parentheses and I am going to do the biconditional with squiggly R. So again, here's the new bit from this page. The biconditional is true when the values are the same. So here's my parentheses. I'm going to put a check mark. Here's my squiggly R. I'm going to use these 2 columns and I'm using the biconditional. So true if and only if false, those are different. True if and only if true, those are the same. False if and only if false, those are the same. False if and only if true, those are different. True if and only if false, those are different. True if and only if true, those are the same. True if and only if false, those are different. And then finally, true if and only if true, those are the same. And that is my statement. All right, just one more little thing, and then you are free of me for another section. Just a couple details. These are going to be relevant to us as we proceed a little further in this section. So if I have a compound statement, which everything we've done today is compound statements. Remember, a compound statement is just me taking simple statements and using connectives to join them together. A compound statement that is always false. Okay. So when you get to that last column, everything in that last column is an F. A compound statement that is always false is called a self-contradiction. Somebody contradicts themselves, that means they are saying something that is always false. Okay, that can never be true. So the reverse, a compound statement that is always true, is called a tautology. Fun word to say. T-A-U-T-O-L-O-G-Y, a tautology. That is a compound statement that is always true. Now, a specific type of tautology is when you have a conditional statement that is always true. A conditional statement that is a tautology, that is called an implication. So that idea of an implication, where we're heading, where we're driving this bus is when we come back, we're going to be back here. We have another class, but then when we come back next week, we are going to kind of do the big thing that we've been driving toward, which is looking at an argument and determining if it's valid or not. And what makes an argument valid is if it's always true under any conditions. If one thing implies another, okay, is an implication. So here's the last thing you're going to do for me today. Exercise 7, you're going to do a quick truth table to determine if the statement, if P, then P or Q, is a self-contradiction, a tautology, or an implication. In fact, I'm going to get rid of one of the choices. Since this is a conditional statement, we would use the specific word. We wouldn't use a tautology if it was. We would use implication. So you're going to determine, is this a self-contradiction or is it an implication by creating a truth table. All right, so we just need two columns here to determine what this is. So first, I'm going to do a column for the parentheses, the P or Q. That's a disjunction. Disjunctions are true when either one is true. So true or true is true. True or false is true. False or true is true. False or false is false. And now I'm going to do the conditional statement from P to P or Q. So I've got if true, then true. That's fine. That's true. If true, then true. Good. If false, then true. That's true. If false, then false. So since the final column is all trues, it is indeed a tautology. Okay, that's sort of the right answer. It's just not specific enough. Because it's a conditional statement, that means it is an implication. And there you go. That's how you identify it.